Which of the following procedures, in addition to studies 1, 2, and 3, would best test whether the amount of heat generated by spent fuel is related to the mass of the spent fuel? And the correct answer here is G, following the design of study 1, but using stainless steel containers containing 0.8 metric tons of spent fuel. Now, the reason this is the correct answer is because they're changing the mass that was used. In study 1, they originally used 0.4 metric tons of spent fuel. If we knew the effect of 0.4 metric tons of spent fuel and we tried a new mass, 0.8, then we'd be isolating the effect of mass, which is why G is the correct answer. Now let's go quickly and talk about why the other answers are incorrect. Here, F says following the design of study 1, but using concrete canisters containing 0.4 metric tons. Well, this is exactly what study 1 already used. And so we're not going to be able to tell the effect of changing mass if we didn't change it. So this is not a good answer. Following the design of study 2, but determining the thermal conductivities of twice as much of each rock type. Well, the rock type is not what we're interested in. What we're interested in is the mass of spent fuel, not the mass of the rock type. And so this isn't changing the mass of the spent fuel at all. And finally, J, following the design of study 3, but determining the rock temperatures 0.5 kilometers from the site of SF burial. Well, this is fortunately dealing with SF burial, but instead of changing the mass of this SF, we're looking at a different distance. The distance 0.5 kilometers. And we're not interested in a change in distance. We're interested in what happens when we change the mass of the spent fuel.